All right, let's try this. All right, so this is going to be function notation, which will be a little bit of assignment 20 and 21. Just remember function notation. We talked about it once already. It's when we write the function of x is equal to x plus 3. And we can also write h of x is equal to 2x squared minus 4. So those are just in what's called function notation. It's easier to write that than it is to write y equals x plus 3 and y equals 2x squared minus 4, because we clearly have two different y values, because we have an x plus 3 and we have a 2x squared minus 4. And if I plugged in x equals to 1, I'm going to get y equals 4 here, and I'm going to get y equals negative 2 here. So I have two different functions. So instead of writing them as y and y, we write them in what's called function notation, which is the function of x is equal to x plus 3, and the function h of x is equal to 2x squared minus 2. So we 2x squared minus 4. So we get the idea that there's two different functions. So at this point, we can do any operation we want with them. So if we say f of x minus g of x, well, that tells us to take f of x, x plus 3, and subtract, not g of x, I used h of x, didn't I? H of x. That tells us to subtract h of x, which is 2x squared minus 4. That right there, a little mosquito running around here. That right there tells us what we need to do. I'm going to find it. I'm going to get it. And then we distribute our negative. We get negative 2x squared minus 4. And then we just combine like terms. We're going to take our negative 2x squared, write it here. We have our equal signs. And then I'm going to take x. That's the only one I have of that one. And I'm going to take x, negative 3, positive 3, and subtract a 4 gives me a negative 1. And so my answer is that. So this is what function notation is, and this is an operation. The operation is subtraction. And we can do both. We can go f of x times h of x, and then all we're going to do is x plus 3, which is our f of x, and then we're going to do our 2x squared minus 4, which is our h of x. And then we're going to distribute the x into each one. I'm going to do it a little differently so you see it a little different ways. And then minus the x times the 4. And then we're going to do plus the 3 times the 2x squared plus the 3 times the negative 4. So I distributed that 3 into each one. So we end up with 2x to the third minus 4x plus 6x squared minus 12. And if we clean that up like everybody likes us to, we get 2x to the third plus 6x squared minus 4x minus 12. So with our function notation, all we're doing is writing it with different letters. So the function of x, so I can plug in x. The function of the function h of x, I can still plug in x. It just lets us clean up our values and makes things a little easier when we get into a little bit harder math. Now, so we've got function notation, and we can do operations with them. We can do subtract, we can do add, we can do all sorts of different things. So now, the other part of the assignments that we've been dealing with is we've been dealing with what's called the remainder theorem. And that has to do with synthetic substitution. So if we look at this and we're going to say, okay, well, I have, let's just take this one right here. 2x cubed plus 6x squared minus 4x minus 12. Make sure it's, look, there we go. If I take that one right there and I divide it by x minus 4, let's say. Let's see if that one's going to work. That one's going to kind of get ugly, isn't it? We'll try it and see what happens. So, if I have this one here and I want to divide, we're just going to use synthetic substitution or synthetic division. So I want to use synthetic division. And I'm going to take and set x minus 4 equals 0. So my x is equal to 4. That's a key step. So I want you guys to make sure that you know that this right here is the key step. You've got to change the signs. We got to set it equal to 0. So we're going to divide by that x value. And so there's a couple other ways to do it. I've seen people just take this and write it right here. 2x cubed plus 6x squared minus 4x minus 12. That means that they know where it comes from. They got all their pieces. That should be a 6. We've got all our pieces, and then we go from there. We always bring down the 2. 2 times 4 is 8. 6 plus 8 is 14. Yeah, this is going to get a little big. Oh, well. 4 times 14 is 56. That gives us 52 because negative 4 plus 56. And then 4 times 52, that's 104. 208. 208, and then that gives us 196. So I started with x to the third. We got rid of that term, so this becomes 2x squared plus 14x plus 52 plus 196 over x minus 4. So that's what my polynomial looks like. Don't forget to write it in polynomial form. Now, the remainder theorem states this. Let me find another colored pen here real quick. There's two choices. Since we got a value right here, the remainder theorem says, well, let's say if there is a remainder, then the remainder is a y value on the line. So in other words, when I plug in x, when x equals 4, then y equals 196. So therefore, when we talk about function notation, f of 4 gives me 196. That's the first part of the remainder theorem. Okay? That's one of the ideas of the remainder theorem. Now, I'll touch to the other part of the remainder theorem here in a little bit, but those two pieces right there are your function notation and your remainder theorem. So in the next video, I'm going to touch a little bit more on function notation and some rational stuff that we're doing. At the same time, I'll touch a little bit more on the remainder theorem. So that's that first one.